Okay, so as I explained earlier on, there have been properties to these functions. Namely, when I was talking about the difference quotient, there was addition and subtraction. Now, how do you do this? Well, if you've got f of x, you can have f of x plus g, we'll say, f of x minus g, then you've got f of x, that would be, the composition of g and x. And then you've got your f of x times g and f of x divided by g. A product and a quotient. Now, if you've got something like f of x plus g, what you're saying is f of x plus g is equivalent, basically, to f of x plus f of g. So if you've got two problems where f of x is equal to, I'm going to go ahead and say 2x plus 3, and f of g is x squared, then that means that f of x plus g is equal to, first, 2x plus 3, this is your f of x, plus f of g, x squared. Which doesn't really get you anywhere in this equation, because f of x plus g will just be x squared plus 2x plus 3. And the same would work for any other problem. If you're adding, you add. If you're subtracting, you subtract them. If you're multiplying and dividing, you multiply or divide the two functions. The harder ones, the ones that people get caught on the most, is compositions of functions. For example, you've got f of x, and you've got g of x. A composition of the functions is f composition. This little circle here is not a 0, it's not an O, it's an open dot, and it stands for composition. So f composition g of x. Now this can be anything, but the way it works is if you've got f of x equal to x squared, and you've got g of x, let's say, is equal to 4x, then here's how it would work. G composition of f will put g of x into f of x as the x. So this part gets put in here. So this would become, instead of x squared, it'd be 4x squared, which would be 16x squared. Or, sorry. It'd be 4x squared, so 16x squared. if it were the other way around, we'll say it was G composition of, F composition of G, then you'd put this in for the x. So it'd be 4 times x squared. See how that works? Now this can get pretty messy later on. For example, let's say f of x, according to Gustafson and Frisk, f of x can be 5x plus 1, and g of x can be equal to 4x minus 3. And we're going to compose 4 g into f. Remember, the second one's going into the first one, okay? So we're going to put 5 times 4x minus 3, the whole thing's going in there, plus 1. That becomes 20x minus 15 plus 1. 20x minus 14 is going to be equal to f with composition of g. Let's say we switch it around and becomes g composition of f. Then you've got 4 times 5x plus 1 minus 3. That's 20x plus 4 minus 3. 20x minus 1. Plus 1. And that is how you do compositions of functions. Now, compositions are probably the more challenging of these two problems that I'm going to cover. Composition is probably harder than what I'm going to cover, which is inverse functions. Why is it a little bit harder than this? Well, once you understand what this is, it's not hard to do the math for it. If you understand the basics of the past chapters I've done, this isn't too hard. Inverse functions simply mean it's the inverse of f of x. In other words, let's say, according to Gustafson and Frisk, let's say y is supposed to be equal to 1 over x plus 3. The inverse is solved like so. Just remember, the reason we do inverses is because it's going to undo what we've done. Basically, we've taken 1 over x plus 3 and we get our y. But this way, we can get with inverses, we can take our y value, plug it in, and our new equation is going to put it back to what the x was. Also note that the domain and range of functions and inverse functions are switched. The domain of a function is going to be the range of the inverse function. And the range of the domain of the inverse function becomes the range of the function. Now, how does this work? First, if there's an f of x here, just switch it out for y. Makes it easy on you. Then we take our y and replace x with it, and the two teleport. The two will teleport to other side of the problem, and now we're ready to go. Now we have to solve for y again. This will be our inverse function. So first we'll divide by 1. So let's not divide by 1. Let's multiply by y plus 3. So y plus 3 okay, so this becomes 1, and this becomes xy plus 3x. Now, here we go. We've got our... Well, first we've got y plus 3 times x. So this becomes y plus 3 times x equals 1. Divide by x, you've got y plus 3 equals 1 over x. Subtract 3, y is equal to 1 over x minus 3. So this means that if we had an x value of 1, in the original problem, it would be 1 over 1 plus 3. 1 over 4, or 0.25. So now, this time, we can plug 1 over 1 over 0.25, which is 4. Subtract 3, we get 1. Notice, I plugged in 0.25 into x here, followed the function, I got 1. But to get 0.25, I plugged 1 into the original function, which was 1 over x minus 3. Sorry, x plus 3. So there you go. This into this created this. This into this creates this. It does the inverse of what the original function was. Now, it'll get a little harder with different problems, but that is the basics of the inverse functions. Just know, it just undoes what the original function does. So if you plug in your older y value into this problem, you'll get your original x value,